Okay, this will be the third and final time for this assessment here. It's solve ratios and proportions. Solving for the variable. Okay, real simple. You're solving for x. There's nothing happening to x. It's x over 4 equals 6 over 5. So we need to cross multiply. That's 24. And then divide that by 5. And x is 4.8. Easy enough. Okay, next one's a little bit different ball game. X minus 3 divided by 3 equals x plus 4 over 4. Okay, here you got to label that A. Label your diagonals A, B, and then C, D. Okay, so then I will be setting these up like this. A times B, so it's always A times B equals C times D. So A is going to be x minus 3, put the 1 there, make that plus negative. We're going to be taking that times 4. Okay, and then we're going to have x plus 4, put the 1 there, and then times 3. And then you got rainbows on each side. 1x times 4 is 4x, and then 4 times negative 3 is negative 12. On the other side, 1x times 3 is 3x, and then 4 times 3 is positive 12. Okay, so I've got x's on each side, so we can get rid of either one. So 3x, I'll minus 3x. This gives me 1x plus negative 12 equals 12. Okay, so I got to get rid of this 12. It's negative, so I plus it. And 1x equals 24. I don't even need to divide here because it's just a 1. Okay, percent sentences. 20% of what number's 80? Remember, it's our percent over 100%, and then is and of. Okay, so my percent's 20, and then after of it says what numbers. So it's going to be x, and 80 goes here. Okay, cross multiply and divide. So 80 times 100 divided by 20 gives me 400. Okay, next one. What is 25% of 144? So 100%, and then my percent's 25, and then it's is to of. Okay, after of it says 144, so 144 is going here. Here after of it said what number, so that's why x went there. But now x is going to go here. You got to pay attention to the of. That's your key thing. If it says of a number, you put the number here. Of what number is different? 144 times 25 divided by 100 is 36. Okay, what percent of 75 is 15? So 100%. Now this time I'm not given a percent. That's what I'm finding. So that's x. Now after of it says 75, and then it says 15. So 15 times 100 divided by 75 is 20. And that's a percent, so it's 20% I just found. Okay, similar triangles. Same shape, different size. The sides are proportional. Proportional means if I set fractions up, they're going to be equivalent. Now this one you could kind of just do mentally. 3 times what? 6. It's 2. What number times 2 is 8? Just think about that. But if you do it this way, you're going to have, that's what proportional means. You're going to have 3 is to 6, what x is to 8, 24. 24 divided by 6 is 4. Yeah, 3 times 2 is 6, 4 times 2 is 8. Makes complete sense. Okay. For 40 miles to kilometers, 1 mile equals 1.6 kilometers. So the ratio is 1 mile is equivalent to 1.6 kilometers. Okay, so it's 40 miles, so I put 40 here and x here. So I just take 40 times 1.6, divide by 1, don't need to, it's 64. So x is 64 kilometers. 40 miles is equivalent to 64 kilometers. Okay, a lot of story problems on this one. It says DV up at the top. It says 5 pounds of pasta serves 14. This makes no sense here. The people needs to be X. Okay. 5 pounds of pasta serves 14 people. How much pasta should you bring to a picnic with 49 people? So I need to find the number of pounds. Well, there's 2. How many units you got underlined? You got 2. So we're going to need to define them and then rate of change. I don't need to draw a line because they're proportional. It's direct variation. Okay. Okay, so my units are pounds and people. It says that the pound should be the Y, the people should be the X. So per pounds per person or people, I guess. You don't really know that, and you don't need to know it because you don't need to do your line. So do not waste time stressing your brain out trying to figure out what the pounds per person is. I don't need it. Now, if I had a line, I would need it, but I don't. Okay? Okay, you want to put those on the bottom. Okay, so 5 pounds to 14 people, and then 49 people, X pounds. So 5 times 49 divided by 14 gives me 17.5. So 17.5. Okay, next. I can mow one lawn in 30 minutes. My friend can mow one lawn in 40 minutes. How long will it take us to mow 5 lawns this afternoon working together? Okay, so I'm finding the minutes and the important units. I have lawns and minutes, so that's 2 units. So we're going to need to identify them and then their relationship. I don't need a line because it's direct variation, so no. And then I'll need to write the equation, or a proportion actually. So minutes and lawns are my units here. It's X, it's Y. So per lawns per minute. The lawns per minute is never given to me, but I don't need to know it because it's direct variation. I don't need my line. I don't need to know it, okay? So I'm just going to use my proportions. So I've set up 3 of them because there's me, my friend, and then us together. You want to put your minutes on bottom. The time should go on the bottom. Just read the problem. 3 makes sense. Lawns on top. So 1 in 30 and 1 in 40. They need to get 5 lawns mowed, so 5 over X. So I need to add those fractions together, 1/30th plus 1/40th. By the way, stop putting 2 over 70. That's wrong. Do you remember in middle school you'd always have to find a common denominator? Well, yeah, that's why we're using the calculator. 7 over 120. And then 5 over X. So I take 120 times 5 and get 600 and then divide that by 7. It's about 86, so X is 86 minutes. Be about an hour and 26 minutes. I don't need it. I just need the 86 minutes. Again, you notice how when I didn't know the rate of change, I did not go use Y minus YX minus X. That's if you need to do the line. Okay, don't need that. Okay, and items marked up 30% from its original price, which was $40, and that 40 took place before it changed by the percent. Find the new price of the item. So you see that word up, we're going to use the arrow to set up our proportion. 100%. Now if it goes up 30, that takes us to 130%. Here's the before, here's the after, and that $40 was before. Okay? Now I know exactly what to put where. 130%, 100%. Then 40 is going with 100, and this X is what I'm figuring out. So 40 times 130 divided by 100, I got 52. Okay, 40% of the test was multiple choice questions. There were 30 multiple choice questions. How many questions were on the test? Arrow is not going to help us here like it did here because it said up. Here it doesn't say anything like that. So I'm going to use the 40%. Now you need to put labels on these. It says that the 40% was multiple choice. So over here, only things I can put there are things that are multiple choice. So was my 30 multiple choice? Yeah, it was. I don't know what the total was, so that's what I'm trying to figure out. So 30 times 100 divided by 40, I got 75. Okay, 3/5 of my paycheck was spent on groceries. If my paycheck is $3,000, how much money would I spend on groceries? So 3/5. Now, like up here, you need to know what the 3 represents. You spend it on groceries. So groceries. Was $3,000 on groceries? No. It goes down here then. And X goes here. I'm trying to figure out how much was spent on groceries. So 3 times 3,000 divided by 5 is 1,800. Okay, then everybody's favorite problem's coming up. 2 cars travel for equal amounts of time. One car travels at an average speed of 70 miles per hour, while another car travels at an average speed of 75 miles per hour. Faster car travels 60 miles further, okay? How many miles did each car actually travel? So those are our 2 answers. There's only 2 significant units. It says dV, so you ain't going to be drawing no lines. That's going to be a complete waste of time. And then I'll need to write an equation. So I've got miles and hours. Hours is X, miles is Y. Miles per hour. Now we actually have those. We got 70 and 75. Okay, but the lines don't do us no good, okay? So I'm going to use ratios. This is one car, this is another car, and I know that their times are equal. Said so, same amount of time. So if the times are equal, the ratio of their distances traveled divided by their speeds have to be equal. Now you know the speeds from up here, 70 and 75. Distances, the only thing we know about the distance is that the faster car went 60 miles further. So further means more. So you put plus 60 right here. That's your faster car. He'd be the one, that's the fast car. He'd be going 60 more. 60 more than what? Well, I don't know. So it's X and X. All right, now we got to use the A, B, C, D method. So A is X. We'll be multiplying that by B, which is 75, 1X. C is X plus 60. That will be 1X plus 60, and then 70. Okay? 1X times 75 is 75X. That's all we got over there. Now over here I got this plus, so I need to multiply. It's going to be 70X plus 4,200. And then our X's are on opposite sides, so we get rid of the 70. So 5X equals 4,200. Now divide by 5. That's our first answer. So 4,200 divided by 5 is 840. So that car went 840 miles. Now to find how far the other one went, you just add a 60 onto it, because you know that that's your slow car. Your slow car went 840 miles, okay? The fast car went 60 more, so 840 plus 60 is 900. Now, I'm going to show you why this works the way that it does. So I know that this is 840. X is 840. So 840 divided by 70. I got 12. Now, let's take 840 plus 60. and divide that by 75, oh, I got 12. Right? 12 equals 12. Okay, 12 is the time, 12 hours the time they travel.